Hello everyone. Today we are going to learn about secant theorem by Nicole Wooten and Soo-hyun Him. End of this lesson, we hope you find the useful information of this secant theorem. Secant theorem. Let's draw a circle with a center O. External point P, we draw the line segment which is called secant PXY PUV. Secant is the line segment extends a chord beyond a circle. Secant theorem is product of Px, Py equals to product of Pu, Pv. What is inscribed angle? Circle and chords. In a given circle, the angle formed by two chords that shares vertex is called inscribed angle. In our proof, angle, there are two secants, PXY, PUV, and draw the two chords. Angle XYU, angle XVU are inscribed. Central angle and subtended angle inscribed. Central angle can be measured by the arc subtended. There's a circle, center O, point A and B on a circle. Given arc AB on a circle centered at point O, we say angle AOB is a central angle corresponding to the arc AB. Let's draw one small circle. For example, a 90-degree angle at the central point O, a quarter circle, which is a 90-degree arc. So it should be clear that the number of degrees in the measure of central angle AOB is equal to the number of degrees in arc AB. Let's draw line segment OQ, draw a chord BQ. So we can prove angle OQB is half of angle AOB. Line OQ and OB are equal because they are radius of a circle. So triangle OBQ is isosceles triangle with the base BQ, and so by the Ponzi-Arcy-Norm, angle OBQ and angle OQB are equal. Central angle AOB is an exterior angle of a triangle OBQ, and it is equal to the sum of two remote interior angle OBQ and OQB. Angle AOB is equal to angle OQB plus OBQ, which is 2 times of angle OQB. Angle AOB is double of angle OQB. So, in other words, angle OQB is half of angle A. The angles subtended by same arc are equal. Circle. Central angle AOB is equal to arc AB. A chord AQ and chord BQ form the angle AQB is equal to half of central angle AOB, and angle AQB is equal to half of arc AB. Another chord AP and BP formed angle APB is equal to AQB. Since they are sharing same central angle and same arc, angle AQB, APB are equal. In our secant theorem, angle XYU and angle XVU are equal by sharing arc XU.
Similar triangle. In order to prove our theorem, we're going to use similar triangle postulate. The word similar in geometry means to have same shape but not necessarily the same size. In relation to definition of similar triangles, there are following properties. The corresponding angles are equal in measure, and the corresponding sides are proportional. There are 3 different postulates: side angle side, angle angle, and side 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 postulate. First, we're going to go over side angle side. If the two proportions of two pairs of corresponding sides are equal and the angle between those two sides is equal, then the triangles are similar. So in this picture, if AX over AB is equal to AY over AC, and the angle between AX and AB and between AY and AC, which is A is equal, then triangle ABC is equal to AXY. AX over AB and AY over AC, and A is equal to A, then triangle ABC is similar to AXY. In this case, the angles that are equal was A, and it was common angle, but it doesn't need to be common always. Once the angles are equal, it works. The second one is AA postulate. Triangle ABC is similar to triangle DEF if angle A and D are equal and angle B and E are equal. In our theorem, we are going to have two similar triangles by AA. You will see this later. Let's prove this. In triangle ABC, angle C is 180 minus angle A plus B because 3 inner angles are 180 in total. Since angle A is equal to angle D and angle B is equal to angle E, by assumption, 180 minus angle A plus B is equal to 180 minus angle D plus E, which is third angle F in triangle DEF. In our proof, Third one is side postulate. Similar triangles and circle. There are two cases that we can see similar triangles in a circle. One is when P is inside of the circle, the other is when P is outside of the circle. Let's look at the first case when P is inside of the circle. Here is circle with center O and P is inside X and Y on the circle. Here is XY which going through point P. Here is another line that connects U and V, and we'll connect X and V and U and Y. and x and u and v and y too. Then angle PVY is equal to angle PXU since these inscribed angles obtain the same arc UI. Next, angle YPV is equal to angle XPU since these are vertical angles when P is inside of the circle. Therefore, we have triangle PVY and PXU is similar by AA postulate. Thus, PV over PX is equal to PY over PU. So PX times PY is PU times PV. For the second case, we have a circle and point P outside of this circle and draw two secant lines which are PY and PU. Then PY meets the circle at point X and PV meets the circle at point V. And we want to connect X and U and V and Y to make two triangles. Angle P is common, and angle PYU and PUX are equal since they are inscribed angle that subtends same arc XV. So triangle PYV and triangle PUX is similar. So PY over PV is equal to PU over PX. Therefore, PX times PY is PU times PV. So when P is outside of the circle, we can draw any secants from P to the circle. But what if the secant line meets the circle at one point? Let's look at this. Secant line meets the circle at 4 points, which are X, Y, V, and U. And look where X and Y carefully from now on. We want X and Y be closer and closer. When X and Y are getting closer, shapes of those two similar triangles are changed together. Now, finally, X and Y meet at one point. How do they look like? It looks different, but it still has same similarity because we just move X and Y slightly and they just exist at one point together. Since secant line meets the circle at one point, that line is tangent line. And we can prove they still have same similarity. Using same drawing, we can prove these. Alright, let's solve some problem. PC is 8, CA is 10, PB is x plus 4, and BD is 3x plus 9. What is the measure of chord DB? So we have this equation, PC times PA is equal to PB times PD. That's going to be 8 times 18 is x plus 4 times 4x plus 13. And we solve this for x. 144 is 4x squared plus 29x plus 42. Calculate this. 0 is 4x squared plus 29x minus 102. So x is going to be negative 9.841, or x is 2.591. But we must discard the first answer since the length of a segment cannot be a negative number. So our dB is 3x plus 9. That is going to be 3 times 2.591 plus 9. So the answer is 16.773. Alright, this is it. Thank you for watching this.